Week is the last week of quarter three. As it's the last week of quarter three, we're gonna finish up Unit 6 with a little bit of a quiz toward the end of the week. And as always, whenever we have a quiz or a test, we have a review that will go along with said quiz or test. And in this case, this quiz review is going to be identical to the quiz that you'll see later on, just with maybe some different triangles, some different numbers, things like that. For this quiz, there are going to be 5 problems in total in which you have to use the law of sines and or the law of cosines to help find any missing side lengths or angle measurements. Now the thing here is that these 5 problems, and I'll click through them quick so that you can kind of see what each of these looks like, and we're going to go through each one in detail. For each of these problems, you will have to determine when you can use the law of sines and when you can use the law of cosines, or even more so, when it is appropriate to use one or the other, because sometimes you have to use, or you have to at least start using the law of cosines, let's say, first. So let's walk through these 5 problems and get a good idea of what the quiz is going to look like later this week. Starting with number 1. I'm given this triangle ABC, and I know the following information. I know that angle A is 53 degrees here, and that angle C is 96 degrees. For side lengths, I only know side length C is 27, so I'm missing the following things. I'm missing angle B, I'm missing side length A, and I'm missing side length B. So you can start almost anywhere. There's really 2 things that I could see you doing right away. The first of which would be taking the law of sines. Okay, and as a reminder, here's the law of sines. Let's write it. That is the sine of A over little a is equal to the sine of B over little b is equal to the sine of C over little c. The reason I say law of sines is the first thing I would do here is because in order to use the law of sines, I have to know an angle and its opposite side length. Well, I know that in C, right? I've got 96 degrees is angle C, and side length C is 27. So I know for sure I'll be using this sine of C over little c. Let's rewrite it right here. Now I can use this with either the A parts or the B parts, depending on what other information I have available. Since I know what angle A is, I'm going to set the sine of angle C over C, little c, is equal to the sine of A over little a. And once we fill in these missing things, these missing pieces, or I should say, once we fill in what we know, we'll see that we only have one missing piece left. So this is going to be the sine of 96 degrees over 27 is equal to the sine of 53 over side length A is unknown. To solve this, I'm going to cross multiply. I like to do my unknown part first. So A times the sine of 96 equal to 27 times the sine of 53 degrees. And I'm solving for A. So instead of finding out what the sine of 96 or the sine of 53, okay, instead of finding those first, I'm just going to get A alone. So I'm actually going to divide by the sine of 96 degrees to both sides. Which gives me A is equal to this whole thing, 27 times the sine of 53 over the sine of 96. What I'm going to do is I'm going to take a calculator. Let's go to the Desmos scientific calculator here. I'm just going to plug that in right away. So make this a fraction. And on the top, 27 times the sine of 53 over the sine of 96. And we get A is equal to 21.68 inches. 21.68 inches, which matches one of the available choices that we have. Let's write that in. A is 21.68. And grab this and put that there as well. All right, I see in chat someone asked, where did I get the 57 from? Do you mean this 53? I just kind of wrote it bad. Maybe that's what you mean there. That's supposed to be 53 degrees. Sorry about that. So now, the next thing, I'm going to find this missing angle. I know that all three angles in a triangle have to add up to 180 degrees, right? So if I take my calculator, where's the calculator? Right here. And I take my calculator, I put in 180, and I subtract the two angles that I know, 53 and 96. This means that the last angle, angle B, must be 31 degrees. So I'm going to write that in my triangle, and I'm going to find that here and drag that to where it belongs. All right, the last thing I can do here is use law of sines again, saying that now that I know angle B is 31 degrees, I can set up law of sines again, and it doesn't matter whether I use A or C in conjunction with B, since I now know angle A and its opposite side length, as well as angle C and its opposite side length. So let's just let's do B and C. So sine of B, little b, is equal to sine of C, little c. Let's fill in what we know. So this would be the sine of 31 degrees over some unknown b is equal to the sine of 96 degrees over 27. Let's cross multiply. So b times the sine of 96 degrees equal to 27 times the sine of 31 degrees. Divide both sides by the sine of 96. You will get b is equal to this whole thing, 27 times the sine of 31 degrees over the sine of 96 degrees. So let's put that in the calculator, make a fraction here. 27 times the sine of 31 degrees, again, make sure you're in degrees here though, over the sine of 96 degrees. This is 13.98. That's close enough to 14, so we'll call it 14 inches. I'll put that in my triangle, and then I'll check my answers, and there is 14 inches there. Questions? Okay, let's move on to the second one. Clear this here. And number 2. For number 2, I'm given another triangle. The following information is known. I've got 2 side lengths, angle and angle B. So angle B is 25 degrees, and the 2 side lengths I have, side length B is 12 and side length C is 28. So I need to find angle A, angle C, and I also need to find side length A. Okay. The first thing I'm going to do is use law of sines, because law of sines is applicable when I've got an angle and its opposite side length. Okay. So what I'm going to do is I'm going to start with the sine of b over little b, and since I know one part of c, I'm going to make that equal to the sine of c over little c. All right. Sine of b sine of c all right, plug in what we know. So sine of 25 over 12 is equal to the sine of some unknown c over 28. Cross multiply. So my unknown is this angle c, so I'm going to do these first. To get 12 times the sine of c is equal to 28 times the sine of 25. Now I'm solving for angle c here, and it's being multiplied by 12, and it's inside of this sine function. So I'm going to divide both sides by 12 and find out what this is. Sine of c is equal to this thing, 28 times the sine of 25. Okay, let's put this in the calculator. Make it a fraction. 28 times the sine of 25, and this is over 12. It's about 0.9861. 0.9861. But remember that this is sine of c is equal to this 0.9861. What I need to find is what the actual angle measure for c is. So how I'm going to do that is take the sine inverse. So in your calculator, you need to go to Functions, Sine Inverse, and then put in 0.9861. Now, instead of typing in 0.9861, because that's technically rounding off a little bit, what you can do is just put in sine inverse of ANS, and that'll pull up your last answer. So that's 80.438 80.44 is what we can round that to. So angle C is 80.44 degrees. Put that in the picture and drag and drop that answer there. Once you know two angles, you can find the third one pretty quickly. Do that by taking 180 and subtracting your two known angles. Subtract 25 and now subtract the 80.44, which we just found. And angle A is 74.56 degrees. Lastly, do one more law of sines. I'm missing side length A, so I'm going to do the sine of, and it doesn't matter, you could do B or C. Okay, I'm going to do B's because that was information that was given to me in the problem. So I'm going to do sine of B over little b is equal to the sine of C, nope, A, sorry. A. Let's fill in what we know. This is the sine of 25 degrees over 12 to the sine of 74.56 degrees over side length A. We will cross multiply. I'm going to do this way first since I have an unknown A. So A times the sine of 25 degrees is equal to, go this way, 12 times the sine of 74.56 degrees. And then divide both sides by the sine of 25. This will give us side length A. So let's put this in the calculator, make it a fraction, and 12 times the sine of 74.56 over the sine of 25. All right, this is 27.369. We'll call it 27.37. I can put that in my triangle here, 27.37, and that belongs there. That in there, and then angle A was the 74.56 that we found degrees. Questions? Okay, well, we've got 3 more problems. We just finished 2. Let's take a little breather. Let's take a 5-minute break, and we'll come back and we'll finish off the last 3 problems on this quiz review. Right now, it is about 1:26. Let's take a 5-minute break, and we'll come back at 1:31. I'll see you then. Welcome back. We are finishing up the quiz review. Let's take a look at number 3. For number 3, I have the following. Okay, I've got a triangle ABC. In this case, I know 2 sides and an angle again, but this time I don't have an angle and its opposite side length. Instead, I have 2 sides and the included angle. Okay, so 2 sides, one here, and the included angle means the angle that's between them. So in these cases where I either have two sides and the included angle or all three sides and none of the angles, I'm going to use the law of cosines, which has two forms. It's got the standard form here and the alternative form. And there are technically, from our notes, this is directly from our notes, there are technically, I guess, 6 law of cosines to consider, but as long as you kind of memorize one of the standard forms and one of the alternative forms and how to use them, then you don't necessarily need to have this full list of 6. Now for the standard form, this is when I'm looking for a side length. Okay, this is for when I'm looking for a side length. And for the alternative form, this is when I'm looking for an angle. More specifically, for alternative form, this is going to be when I know all three sides, but I don't know any of the angles. Okay, I'll start with the cosine of the angle across from the longest side length. Now for the standard form, this is going to be when I'm finding a side length, and this will be for the side length opposite of my known angle. So for this problem, since I have two side lengths and an included angle, I'm going to use the standard form starting with b squared, because b is my known angle. So it's going to be this one here. B squared equals a squared plus c squared minus 2 AC times the cosine of b. So let me write that first, and then we'll get this out of the way. So b squared is equal to a squared plus c squared minus 2ac times the cosine of angle b. Let's fill in what we know. B squared, I don't know length b, is equal to a squared is 13 squared plus c squared is 17 squared minus 2 times a times c, so that's 13 again, times 17 again, times the cosine of angle 34. Now, this I should be able to just put right into the calculator once I've plugged stuff in. So b squared is equal to, let's find out. 13 squared plus 17 squared minus 2 times 13 times 17 times the cosine of 34 degrees. So this will end up being, let's double check, make sure I got everything typed in there right. Yep, this will end up being 91.565. Now remember that this is b squared though. I don't want to solve for b squared, I want to solve for b. As such, I need to take the square root of both sides. B is equal to, here I can take the square root and then just type ANS to pull up my last answer. So B is equal to 9.568 inches. We'll call it 9.57 to round up. 9.57 inches. Which does appear right here. All right, now that I know what side length B is, I've got an angle and its opposite side length. So I no longer have to use law of cosines if I find that law of cosines is more confusing or just takes longer to use. I can now use law of sines because I've got an angle and its opposite side. So I can say the sine of, let's do A and B, the sine of angle A over little a is equal to the sine of angle B over little b. Fill in what we know. Sine of angle A over 13 is equal to the sine of 34 degrees, or 9.57. Cross multiply. 9.57 times the sine of angle A is equal to 13 times the sine of 34 degrees. Divide both sides by 9.57. Get the sine of A alone. And I get the sine of A is equal to, let's put that in a calculator now. Make this a fraction. 13 times the sine of 34 degrees over 9.57 is 0.7596. Of course, this is the sine of A, and I just want A, though. So I'm going to take the sine inverse of this. So I can say sine inverse and then A and S to pull up my last answer. A is equal to 49.43. My answer here must have been a little bit of a rounding error. So 49. Let's see, can I change that? Yes, not. So that was 49.44, we'll call it. A. All right, the last thing to do here, luckily I accidentally cleared my screen here, but luckily the last thing I need to find is the last angle, and I can do 180 minus my two known angles, and that'll give me the remaining angle measure. So pull up my calculator again, and 180 minus 49.44 minus 4 is 96.56. Last angle measure here, 96.56, right here. All right, two more and then we're done. This is another case, number 4, this is another case where I've got two sides and the included angle. So that tells me I'm going to be using law of cosines again. And more specifically, I'm going to be using the standard form starting with a squared because this is the side across from my known angle. So that's going to say a squared is equal to b squared plus c squared minus 2 times b times c times the cosine of angle A. If you remember from the actual lesson, we said an easy way to remember this is what letter you start with, that's the same letter that you end with. So a squared, cosine of A. Everything in the middle, those are going to be the other two. So B and C in this case. Let's fill in what we know. B is 30. So every time I see a B, I'm going to replace it with 30. And C is 23. So every time I see a C, I'll be replacing that with a 23. 30 squared plus 23 squared minus 2 times 30 times 23 times the cosine of angle A is 52 degrees. This I can put right into a calculator. 30 squared plus 23 squared minus 2 times 30 times 23 times the cosine of 52 degrees. This is 579.387. And of course, take the square root because I don't want to solve for a squared. I want to solve for a. So in my calculator, I'll do the square root and then ans to pull up my last answer. That'll be about 24.07 inches. Okay, so now I've got an angle and its opposite side. So this allows me to use law of sines from this point on. So I can say, it's over here, I can say the sine of A over little a is equal to the sine of B for little b, filling in what we know, so that's the sine of 52 over 24.07 is equal to sine of, I don't know what b is, over 30. Cross multiply. 24.07 times the sine of b equal to 30 times the sine of 52 degrees. And divide both sides by 24.07. You'll get the sine of b equal to whatever this is. So let's pull up my calculator again. And we've got, let's see, make it a fraction, 30 times the sine of 52 over 24.07. So the sine of b is equal to 0.9821. And then take the sine inverse to find what b is. Sine inverse ans. This is about 79.15 degrees. All right, so I'll select that and I'll bring that up right there. Here we said side length A is 24.07, so we can put that in there as well. And then angle C, this is going to be 180 minus the two angles that we now know. So 180 minus 52 minus 24.07. And this is 103.93. Oh, no, minus 52 and 79, sorry, 79.15. 48.85. There we go. All right, any questions on number 4 here? All right, in that case, let's move on to our last problem. Let's clear this. And the last problem that we'll have today is this triangle. I know all 3 sides, but I don't know any of the angles. So when I know all 3 sides, okay, when I know all 3 sides, but I don't know any of the angles, I'm going to be using the alternative form for the law of cosines. More specifically, I'm going to use the alternative form starting with the side length that is largest. Okay, the longest side length here is 26, and that is little a, okay, side length a. So I'm going to start with cosine of a equals this one here. So cosine of a equal to b squared plus c squared minus a squared over 2bc. Filling in what we know, cosine of a is equal to b squared is 16 squared plus c squared is 21 squared minus a squared is 26 squared. And this is over 2 times b times c. So 2 times 16 times 21. Let's find out what that is. Here I'll need to make a fraction, and on the top, 16 squared plus 21 squared minus 26 squared. And this is over 2 times 16 times 21. So cosine of A, make sure we typed everything correctly. Looks like we did. Cosine of A is equal to 0.03125. And then because this is the cosine of A, I want to find what actually A is. So I take the cosine inverse of both sides. Cosine inverse of, answer 88.21. I'm guessing that was a little bit of a rounding thing from when I did it the first time. So 88 point, looks like 44 degrees is what we're using here. No, 88.2, sorry. This one here. All right, so 88.2 degrees is angle A. And now that I know an angle and its opposite side length, I no longer have to use law of cosines. If I'm more familiar with, and I prefer the law of sines, I can now say the sine of A over little a is equal to the sine of B over little b, and solve for the unknown there. So if I do that, that ends up saying that the sine of A over little a is equal to the sine of B over little b, And filling these in, that'd be the sine of 88.2 over 26 is equal to the sine of b is unknown over 16. Cross multiply. Do my unknown diagonal first, so that'll be 26 times the sine of b is equal to 16 times the sine of 88.2. Divide both sides by this 26. And we get the sine of b equal to whatever this thing is in the calculator. So again, go back to the calculator, clear this up, plug this in now. So a fraction, 16 times the sine of 88.2 over 26. Sine of b is roughly 0.615. But I don't want the sine of b, I want b. So I take the sine inverse. I can say ANS for my last known answer. B is 37.95 degrees. All right, so write that in the triangle and that here. Lastly, I only have one missing angle left. Luckily, I don't have to go through all this if I don't want to again. I can just say 180 minus my two known angles. So 180 minus 88.2 minus 37.95, and I get 53.85 degrees. Okay. So I see in chat questions, like most of this is just plugging stuff into formulas. That's exactly right. Okay, so primarily, I mean, as long as, oh, let me clear this so I can show you. As long as you follow your law of cosine, so if I go directly from the notes, okay, so this is directly from our materials here. Law of sines, a law of cosines, assignments, notes. There we go. Okay, as long as I know where my law of sines is and my law of cosines are, then I should be able to just plug in what I know using these two, okay, using these two laws into a calculator, and as long as I follow the steps that we used for these 5 problems, we should be good on the 5 problems that are going to be on the quiz. Because what you see on the quiz review, these 5 problems, seem very, very similar to what is going to be on the quiz itself. What were the side lengths for number 1 again? You got it. Number 1, we had 31 degrees, 21.68 inches, and 14 inches. So number 1 was 31 degrees, 21.68 inches, 14 inches. Number 2, 74.56 degrees, 80.44 degrees, and 27.37 inches. Number 3, 49.44 degrees, 96.56 degrees, 9.57 inches. Number 4, 79.15 degrees, 48.85 degrees, and 24.07 inches. And number 5, 88.2 degrees, 37.95 degrees, and 53.85 degrees.